weather station using Arduino. This project can help us to monitor wind speed, temperature, humidity, and air quality by using anemometer, DHT11, and MQ135 sensor. We are using Arduino to calculate and display the information on the laptop screen. This Arduino-based weather station system can be used to monitor the atmospheric conditions of remote areas where we cannot survive or stay. This project presents a design of weather monitoring system. It displays data collected at some predetermined sampling interval, with date and time stamps, for later retrieval with real-time supervision and analysis of different environmental parameters, like temperature, humidity, wind speed, and air quality. Such type of system can be used in controlled environment like agriculture farms and aquaculture. The idea behind it is mainly weather monitoring and forecasting at microecological level, monitoring upcoming situations to alerts during unfavorable circumstances. This is the connection diagram of our project. RTC module has 4 main pins: VCC, ground, SCL, and SDA. VCC pin is connected with the 5-volt pin of Arduino. Ground pin is connected with the ground pin of Arduino. SDA and SCL pins of RTC are connected with the SDA and SCL pin of Arduino. DHT11 sensor has 3 pins: 5-volt, ground, and output. 5-volt pin of sensor is connected with the 5-volt pin of Arduino. Ground pin of sensor is connected with the ground pin of Arduino. Output pin is connected with the 0 pin of Arduino. MQ135 air quality sensor module has 3 main pins: VCC, ground, and Dout. VCC pin is connected with the 5-volt pin of Arduino, and ground pin is connected with the ground pin of Arduino. Dout pin is connected with pin number 8 of Arduino. Anemometer is made up of a reed switch, which will give a high signal when it comes in the magnetic field. Reed switch has 2 wires. One is connected with the 5-volt pin of Arduino. Second pin is connected with a ground pin through a 10 kilo ohm resistor. Joint of reed switch and resistor is connected with pin number 7 of Arduino. This is the code of our project. We will include the library of DHT11 sensor. To include the library, we will write #include DHT.h. Output pin of DHT11 sensor is connected with pin A0 of Arduino. To use the I2C pins of Arduino, we will include its library in the program. To include the library, we will write #include wire.h. To include the library of RTC, we will write #include ds3231.h. T is a structure type variable. MQ135 air quality sensor is connected at pin number 8 of Arduino. Sensor state is an integer type variable. It is used in the program to store the status of input pin. Initially we have set its value to 0. Reed switch is connected at pin number 7 of Arduino. Void setup is a function in which we will declare the input pins and also initialize the serial communication. 9600 is the speed of data communication. Data will transmit between computer and Arduino with the speed of 9600 bits per second. Then we declare pin number 7 and 8 of Arduino as input pin. Wire.begin will initialize the I2C pins. DS3231 in a DS3231 control INTCN. It will initialize the RTC. T.hour is used to save the hour value of time. T.min is used to save the minute of time. T.second is used to save the second value of time. T.mday is used to save the day of month. T.mon is used to save the month. T.year is used to save the year. By entering the values of these variables, we can set the date and time. DS3231 set T is used to save the values of time and date in the RTC. Void loop. This function will run over and over again, so whatever we write inside, it will repeat forever. DS3231 get T is used to fetch the values of time and date from the RTC. Serial.print T.mday will display the day of month on the serial monitor. Serial.print.t.mon will display the month on the serial monitor. Serial.print.t.year will display the year on the serial monitor. Serial.print.t.hour will display the hour value on the serial monitor. Serial.print.t.min will display the minute on the serial monitor. Serial.print.t.second will display the second value on the serial monitor. Delay 1000. This function will generate a 1 second of delay. DHT11 DHT a pin. It will read the value of the sensor connected at pin A0 of Arduino. Serial.print DHT.temperature. It will print the reading of temperature on the serial monitor. Serial print DHT.humidity. It will print the reading of humidity on the serial monitor. Serial print ln is used to change the line. Sensor state equal digital read MQ sensor pin. Digital read is a function which will read the status of pin number 8 and store its value in a variable sensor state. If sensor state value is high, then Arduino will print the message on serial monitor that air quality is good. If sensor state value is low, then Arduino will print the message on serial monitor that air quality is bad. RPM is an integer type variable. Its initial value is set to 0. Rotate is a function which will count the RPM and return the value of RPM. Serial print RPM will display the airspeed on the serial monitor. I and J are two integer type variables. When read switch will come in front of the magnet, then it gives a high pulse at its output, and it increases the value of variable count by 1. Now, we will write a code on this software. After writing the code, we will save our project. Now we will compile our code. For doing this, press this check button. If there is any error in the code, or the code is incorrect, it can be seen on the message screen below. If the code is correct, we can upload it to our Arduino hardware board. For this, we will first connect the Arduino board to the USB port of our computer. Now we will go to the Tools menu and select Arduino Uno. Then, we will go to the port option and select the port at which Arduino is connected. Now, to transfer this code to our hardware, we will press this arrow button. Connect a red wire with one end of the read switch. Connect a 10 kilo ohm resistor with another end of the read switch. Now connect a orange wire at the joint of read switch and resistor. Connect a black wire with another end of the resistor. Cover the joints with insulation tape to avoid any shorting between its two terminals. Connect a red wire of read switch with 5-volt pin, black wire at ground pin, and orange wire at pin number 7 of Arduino. Now connect the red wire of DHT11 sensor with 5-volt pin of Arduino, black wire at ground pin, and yellow wire at A0 pin of Arduino. Connect the red wire of the RTC module with 5-volt pin, black wire with the ground pin. Connect the yellow wire with SCL pin, and green wire with the SDA pin of Arduino. Now connect the red wire of MQ135 sensor with 5-volt pin of Arduino, black wire at ground pin, and blue wire at pin number 8 of Arduino. Now we will power up our circuit and test its functionality. We will rotate the anemometer with the fan. We can see the reading of airspeed on the serial monitor. We will now use a matchstick to increase the surrounding temperature of the sensor. We can see that the temperature and humidity reading is changing on the screen. Now we will use a paper to generate the smoke. When we put the smoke near the sensor, then Arduino will print the message that air quality is bad. When there is no smoke near the sensor, then Arduino will print the message that air quality is good. Arduino is printing the readings of sensor with date and time. Our project is working perfectly. We hope you enjoyed the video and learned something from it. For any help in your project, or to clear your doubts, you can contact us. on our student care number 7007957715. To purchase the items used in the video, you can visit our website www.erolltech.com. You can order us on our WhatsApp number also. Thank you so much.